Okay, here's the last part of piecewise functions and graphing them. We are going to be working with graphing a line. So let's just review line graphing. And we did a review assignment early in the year on this. So remember that if you have the equation of a line, that this piece right here is the y-intercept, and this piece right here is the slope, which is the rise over the run. So if we were going to graph a line, something like y equals, or let's use f of x, because that's what you're going to see with piecewise functions. You're going to see function notation. But remember that if we have f of x equals negative x plus 4, remember that y and f of x are the same thing. Okay, so they just mean the same thing. So in this case, the slope is equal to -1. The y-intercept is equal to 4. And so if we were to graph this, we would go up 1, 2, 3, 4, and we'd have that dot, and then we go down 1 over 1, and this line that we would be using, would be something like that. So it would be that line. So that's graphing one line. Piecewise functions have us graph several different lines. Just remember that if it's just two side notes, that if it's y equals a number, that is a horizontal line. And if it's x equals a number, that is a vertical line. That'll come into play. And really what the one that we will be using today will be this one right here, y equaling a number. So here's the type of question that you're going to have to do. It'll be something like this. It looks more involved. Don't let it freak you out too much. But basically, we're going to draw two different things. The first one is the line. If we were to just look at this part right here, this basically says the line y equals 4 when x is less than or equal to -3. The second one, this one, says graph the line y equals -6x plus 32 for x greater than 4. Now, that one's going to be a little bit more challenging because we're going to have to kind of figure out how to graph that on our graph right here. So let's look at that. If we were to kind of look at what happens, 1 second. So if we were to kind of look at the first one, let's look at the green one. That's the easy one. Graphing the line y equals 4 when x equals 3. Remember, y equals 4 is a horizontal line when x equals -3. So -3 or less. So if we go to -3, which is right here, and we go to 4, because that's what we're supposed to graph, go to 4, -3, and we're supposed to use this line. That is the line y equals 4. If we use that line when x is -3 or less, that would be that graph. So that's the graph y equals 4 when x is negative 3. Now, the second one's a little bit harder because that's a y-intercept of 32. That's going way off of our graph. So when you think about that, that one's going to be a little bit more challenging. So let's talk about how we might do that. To graph the line y equals negative 6x plus 32. That's a big y-intercept. That's going to be hard to fit in our graph. This is the slope. So the slope is negative 6 over 1. Well, so we can do a little side note. If x is equal to 4, okay, so if x is equal to 4, then we would have y would equal negative 6 times 4 plus 32. If you do that math, y is equal to 8. So 4 comma 8 is a point on this line. Well, we can graph that on our thing. 4, 8 goes right there. That point right there. Now, if we use this slope, 6, so if we use this point, 4, 8, and we use this slope, negative 6 over 1, so go down 1, 2, negative 6 over 1 would put us like right here. And we're supposed to use this line when it's less than or equal. So we should, just greater than. So we should put that. Greater than 4 would put us, whoops, sorry, my graph got a little messed up there. So that's down 6. So if you notice what I did to get that new point right here, I went down 6 over 1. Hopefully you remember that from our work earlier this year. That's the line. That line right there is the line y equals negative 6x plus 32. So that's all that you'd have, because notice that our restrictions on this are only including x less than or equal to negative 3 or x greater than or equal or greater than 4. So we have just a missing piece of the graph, and that's fine. That's where we were restricted. Let me show you one more. I think I have one more on here. Let's take this one right here. This particular one, let me scroll out a little bit. This particular one says, okay, we're going to graph this function, and we're going to graph 3x plus 7 when x is less than 1. So it's the line 3x, the line y equals 3x plus 7 if x is less than or equal to 1, negative 1. And then it's the line 3x plus 1, the line y equals 3x minus 1 when x is greater than 2. So let's start with the first one, 3x plus 7. Like if I graph that everywhere, let's say I graphed that line everywhere, 3x plus 7. So we'd go up to y-intercept of 7. Slope of 3 means we'd go up 1, 2, 3 over 1. And we'd graph this line, right? So we'd graph this line, come down here, go like this. But we don't use that line everywhere. Notice that we only use that line from -1 and smaller. So we really don't want, my line's a little bit off, so I'm going to erase it a little right now. We don't want this whole line. When you think about this line right here, see if we can get it to straighten out for us. That's the whole line. We don't want that whole line. In fact, we don't want any part of this line going this way. So we really want that line to start right here and go this way. That's all the part that we really want. We don't want that other part. So if I erase that other part, that's the only part that we want. We want it to start here and go that way. That's x values that are less than or equal to -1. Now for the blue line, the y-intercept is -1, and the slope is 3. So from -1, we go up 1, 2, 3 over 1, and we draw this blue line. But again, we don't need the whole line. Remember, we only want this line when x is greater than 2. Well, here's 2. So we only want this line starting at 2, but not equal to it, and bigger. So we only want that part of that line. So we can erase this part, and that's what our graph would look like. It's another piecewise function. There are 2 pieces to that function. So if you need more help, please jump on, and I'd be glad to help you.